I was staring at a screen of code this morning, just this massive wall of text,
Yeah, we've all been there.
right? And it hit me. We usually treat this stuff like a recipe, right? Like step 1, preheat the oven. Step 2, mix the flour.
Step 3, hope you don't burn the house down.
Exactly. But then every once in a while you zoom in, you look at a specific line, or maybe just a single word choice, or where a specific tool is placed.
And you realize it's not just a recipe.
No, it's philosophy. It's an actual debate about how we perceive reality and organize our thoughts.
That really is the shift. That's the massive difference between a coder who just hacks something together and a real software engineer. Or, to use a term from our source today, a software plumber.
I really love that title.
Yeah.
Software plumber. It sounds so practical, but completely essential.
It sets the perfect tone for what we're looking at.
It does.
Yeah.
So for everyone listening, today we are taking a deep dive into a technical blog post that actually just dropped today,
Yeah.
Monday, February 23, 2026.
Hot off the presses.
Yeah. It's from a developer who goes by the moniker Ang over at kinangmang.org. And the title is a bit of a mouthful. It's Notes on Haskell Programming Part 65, Refactoring Local Helper Function and Embracing Pure.
Part 65. I mean, that is what grabbed me immediately.
Right.
This isn't a Hello World tutorial. It's not someone trying to sell you a bootcamp course. This is someone just showing up day after day, documenting the grind of the craft.
Which is exactly our mission for this deep dive. We aren't just going to read code to you. We're going to basically look over Ang's shoulder as he tidies up his workshop.
It really feels like watching a craftsman at work.
It totally does.
Mm-hmm.
And we're going to talk about 2 universal ideas that came out of this session. One is cohesion, which is essentially about where you put your tools.
Mm-hmm.
And the other is much deeper. It's a battle over a single word, the word return versus the word pure.
And that second one, that is going to mess with your head a little bit, especially if you come from languages like Python or Java.
Oh, absolutely.
It really challenges what you think you know about how languages actually think.
Well, I am fully ready to have my brain melted. But before we get to the philosophical stuff, let's set the scene.
Let's do it.
What is this software plumber actually working on? What's the context here?
So Ang is working on a command line tool. And specifically, he's refining a function called validate args.
Validating arguments.
Exactly. As the name implies, it's basically the bouncer at the door. It takes whatever the user typed in and checks if it's valid before letting it into the main program.
Okay, standard procedure. You don't want bad data crashing the whole system.
Right. But part of this validation involves checking a file. And the program expects a text file.
Okay.
It doesn't want an image. It doesn't want an executable program. It doesn't want a zip file. It wants text. So Ang needs a way to distinguish between them.
Which, if you think about it, is kind of a weird problem for a computer.
How so?
Well, to us humans, a picture looks like a picture and text looks like text. But to a computer, underneath it all, it's just a long stream of ones and zeros.
It's just binary soup.
Yeah, exactly.
So Ang has this helper function called isText. And before the refactor, before the actual cleanup we're talking about, this function is sitting in the global context.
Okay, global context. Define that for the non-Haskell folks listening. Or for me, honestly.
Sure. Think of it like the floor of your garage. If you define a function globally, it's just sitting there right in the middle of the floor.
Right.
Any other function in the file can see it. They can trip over it or potentially try to use it. It is visible to the entire universe of that file.
Even if validate args is the only function that actually needs it.
Precisely, and that is the first problem.
I mean, it works, right?
Oh, it works. The code runs fine. But it violates the concept of cohesion.
Cohesion. You hear that word thrown around in engineering meetings a lot. It sounds very, I don't know, expensive.
It does sound like a buzzword, but it's actually a very simple idea. It just means things that belong together should stay together.
Okay.
If isText is a specialized tool that only validate args uses, you don't leave it out on the garage floor where the neighbor can borrow it.
You put it in the specific drawer.
Exactly. You keep it right next to the job it's meant for.
So the first move Ang makes is basically a location change. He's just tidying up.
Right. He performs a refactor. He moves the definition of isText inside the validate args function.
Making it a local helper.
Exactly. In Haskell, you do this with a where clause or a let block. It effectively hides the tool from the rest of the world and makes things much more cohesive.
I do want to pause on the isText function for a second, though, because the source post actually shows the code for how he checks if a file is text or binary.
It's a neat little trick.
It is, because how do you tell the file is binary without reading the whole thing? If I drop a massive 10 gigabyte movie file into this program, I don't want it to freeze for 10 minutes reading every single byte just to say, nope, not text.
That would be a complete disaster for performance. So Ang uses a smart shortcut. The function uses something called bstring.take224.
So it literally only grabs the first kilobyte of data.
Just the first 224 bytes.
A taste test.
A taste test, exactly. And then, and this is the technical bit, it checks if there are any null characters in that sample. The code is checking for equals equals 0.
Translate that for us. What does finding a 0 mean?
Well, in standard text encoding, like the characters that make up the words we read, you basically never have a byte that is all zeros.
Okay.
But in binary files, like images or compiled code null bytes are everywhere. They're just part of how the data is structured.
So if it finds a single 0 in that first kilobyte, it just screams false.
Right. It says, I found a 0, this is binary, shut it down.
That's brilliant. It's like checking if a drink is hot. You don't have to drink the whole cup, you just touch the outside of the glass.
That is a perfect analogy. And by moving this logic inside the parent function, the whole thing becomes much more cohesive.
The workspace is tidy.
Exactly. No one else needs to know how we check for null bytes. It's a private detail now.
Okay, so step 1 is done. The workshop is clean. The specialized wrench is in the correct drawer.
But then Ang looks at the code again.
And he sees a word, a keyword that we see everywhere in programming. Return.
And here we go. This is the main event.
He decides to delete it. He swaps the word return for the word pure. Now, here's the part that I found fascinating, and I think a lot of listeners might be confused by it at first. Ang admits, straight up in the post, that in this specific context, the I/O context, these two words are functionally identical.
They are completely equivalent here. The compiler does not care.
So why change it? If I'm a manager reviewing this code, I'm thinking, you are wasting time swapping synonyms. Why does this matter?
Because code is read by humans. And for a human programmer, the word return is a false friend.
A false friend.
Yeah. It's a concept from linguistics. Have you ever studied another language and found a word that looks exactly like an English word but means something totally different?
Oh, definitely.
That's a false friend. You assume they mean the same thing, so your brain brings all this baggage from your native language, but in the new context, it's completely wrong.
So return is a false friend in Haskell. Break that down for us, because return is in pretty much every language. It's in Python, Java, C. What does it mean in those languages?
In almost every other language, return implies a control flow jump.
Like an exit sign.
Yes. It means stop what you were doing, exit the function immediately, and go back to where you came from.
If you write code after a return statement in Java, it doesn't even run.
The compiler will literally throw an error. It's unreachable code.
But in Haskell?
In Haskell, return doesn't do that. It does not halt execution. It doesn't jump anywhere.
That feels, it feels like a trap.
It is a trap. Using the word return confuses programmers coming from other languages because it brings all that mental baggage. They expect an exit, and Haskell just keeps going.
So why is the word return even in Haskell if it doesn't return anything?
It's essentially a legacy alias. It was kept for backward compatibility and to make things look a bit more familiar to older programmers back in the day.
Wow, so it creates this massive mismatch between your mental model, what you think the code is doing, and the reality of what it's actually doing.
Exactly. And when your mental model is wrong, that's where bugs happen.
So Ang switches to pure, which I have to say sounds very philosophical, pure.
It does sound a bit elevated, but it's actually a very precise mathematical term.
So help us visualize this. If return makes us think about walking out of a room, what should we visualize when we see pure?
Well, Ang uses this explanation of lifting.
Lifting, okay.
Imagine you have a normal raw value, say the number 5. It's just sitting there.
A raw integer.
Got it. But in Haskell, especially here, you're operating in a specific context. In this case, it's the I/O context.
The input-output context.
Yeah, you can't just have a raw number floating around in the I/O world. You have to lift that value into a wrapper or a context.
And Ang actually prefers a different term for this, right? Embedding.
Yes, embedding. And I think that's a brilliant nuance to discuss.
Why embedding over lifting?
Because lifting sounds like an action. It implies you're moving something. But embedding implies placing a value into a context very carefully, without any side effects.
Ah, I see.
It's not about leaving a room, like return. It's about packaging an item.
So you take your raw number 5 and you wrap it in a protective bubble. And that bubble is the context.
Yes. That is what pure does. It just safely embeds the value into the necessary context so the rest of the program can handle it.
I love that visual. A raw number in a protective bubble. So when I see pure in the code, I know exactly what's happening. No exits, no jumps, just packaging.
Precisely. It aligns the code you read with the reality of what the computer is doing.
Now, there's a moment in this blog post that I found really striking.
Oh.
Yeah. Note the tone of the post. Eng calls himself an old software plumber. He's writing part 65 of the series. He's clearly experienced. But he stops and openly admits that he is still wrapping his head around the historical, mathematical reasons for the distinction between return and pure.
That is such a vital part of this whole deep dive.
Why do you say that?
Because it models the learner mindset perfectly. Haskell had this reputation for being incredibly academic. People think you need a math PhD just to write a simple script.
It can be very intimidating for newcomers.
Right. But here is an experienced developer saying, look, I know pure is better here because it avoids confusion. I know how to use the tool, but I don't know the full mathematical history yet.
It's so validating. It proves you can use a tool effectively, even if you are still learning the deep theoretical backstory.
Exactly. You don't need to know how the combustion engine was invented to drive a car to the grocery store.
And he even makes a promise in the post to revisit the math in a future update.
Which shows that learning in software is always iterative. You solve the problem in front of you, you improve your mental model, and you keep going.
It's fantastic. So to sort of summarize the two key moves Eng made here.
Yeah, let's recap.
First, we have localizing helpers, moving the asText function inside to improve cohesion.
Tidying up the workspace, putting the tools where they belong.
And second, switching from return to pure to match the actual semantics of the language.
Saying what you mean and meaning what you say.
Which brings up a great point for you, the listener. Because whether you code in Haskell or Python or you don't code at all,
the lesson is exactly the same.
It really is. It's all about choosing names that accurately reflect reality, not just falling back on habit.
We all use legacy aliases in our lives. Words that we just use because we've always used them, even if they're misleading.
That actually leaves us with a really provocative thought to chew on.
Let's hear it.
If return is a misleading name in Haskell because it relies on old habits, what other terms do we use in our daily work or our studies that we take for granted?
Oh, that's a great question.
Words that actually misrepresent what we are genuinely doing.
I guarantee everyone listening has at least one phrase they use at work that completely obscures the reality of the task.
Definitely something to mull over today. Well, that wraps up our look at Eng's refactoring journey.
It was a great read.
It really was. Thank you for joining us on this deep dive, and we will see you in the next one.